This will be the third and final video for Bryan Triple Flex quiz number 3. This will be the final video for the Bryan Triple Flex series. We pretty much have covered everything that you needed to see in the wiring diagrams. If you have a place that you store information, either on a laptop, iPad, iPhone, cell phone, whatever, all of this information from the terminology page, the IOM, and the 2 Honeywell documents here, probably good information to store for future reference. Yes, you can always search these on Google and probably download them again, but they get harder and harder to find. This Bryan Triple Flex IOM, I guarantee you won't find that on Google, because it's something I have had for a long time, and you probably won't find that again. The terminology page, of course, is my document, so you would have to download that. But having this information available to you, or if you need it, let me know. I can send it to you. But you click on this, you go here where the arrow is pointing, and you click that, and it will download, and you can save it to wherever you want to. But information like this is the kind of stuff that can help you be more efficient on the job, because you need this information at times, and you don't want to spend a whole lot of time looking for it. So let's go over a few things here. I wanted to go over some of the particulars about the Honeywell Solo controller. I mentioned a reset button. That is actually right here on the front of it is a reset button. It has indicator lights for power is on, flame is on, and if it goes into alarm, which means it needs to be reset. When you looked at all the wiring that came in here on the right or the left-hand side, most of that was 120 volt. Most everything on this side is either low voltage or 24 volts or sensor inputs. They do that intentionally. The plug here, I think this was the plug for the pulse width modulation output, or maybe the UV scanner. Here is a terminal here if you're going to use the actual spark ignition transformer built into the controller for the spark ignition. There it is right there. They make 2 different versions of this. Here's the table. They make a hydronic version and a steam version. If it's a steam boiler, it's only available in a 120 volt model. For the hydronic heating or hot water boiler, you can get either the 24 or 120 volt. Modulation outputs, these are 3 different distinct types of modulation signals. Pulse width modulation is one type, 4 to 20 milliamp is another type, and 0 to 10 volt is another type. So when you see this, I don't think they separate them the way they should, but these are 3 separate types of modulation signals. You can have 2 different types of flame detection, either a flame rod or an ultraviolet scanner. The flame rod, probably more typical on residential and light commercial kind of equipment, where you just have a rod, and that rod uses the flame and the ability to pass current through the flame to detect there's flame present. The ultraviolet does it by radiation, ultraviolet radiation of a combustible flame. That's how it knows there's a flame present. Some other things about the controller: if you had a sensor fault, maybe you wanted to test and see if a sensor was good, you would need to unplug it and then go to the chart that we looked at earlier and measure the resistance of that sensor. If you left the boiler turned on when you unhook that sensor, and it's okay, you can do that, but you would get a fault. It would say the sensor is out of range, either low or high, depending on whether it's a negative or positive temperature coefficient. I probably should explain that. On the sensors here, they were a negative temperature coefficient sensor. NTC. If it says PTC, that's positive temperature coefficient. Positive temperature coefficient means that as the temperature goes up, the resistance goes up. If it's negative, it's the opposite. As the temperature goes up, the resistance goes down. That's the difference between PTC and NTC. So there was your sensor part numbers if you need that. Here's a scanner, UV scanner, certain flame rods that Honeywell makes. I want to get down here to the specifications here. This is very important information. You see here where it says approvals, Underwriters Laboratory, CSD1. CSD1 is something that you definitely need to understand or know what that means. Underwriters Laboratory, UL listed. You know, anytime you see UL listed on electrical components, you know that it has met certain standards. But the CSD1 standard is a controls and safety device standard for boilers, and it's important to know that. So I'm going to try this. I search CSD1, and I want to go to the asme.org page, and here you see that ASME stands for American Society of Mechanical Engineers. CSD1 is controls and safety devices for automatically fired boilers. This is a code that ASME has designed for automatically controlled boilers, and if you wanted to buy the 2018 version of the code, you could buy it here for $103. Knowing exactly what all is in the code is going to be important, and this is something I probably need to do a class on for journeyman down the road. But just knowing that CSD1 stands for Controls and Safety Devices for Automatically Fired Boilers, I may put that on the quiz, but it's important because all of these approvals are what makes this controller safe and probably what makes it more expensive than anything. You know, the plastic and the circuit boards and all that stuff, probably not that expensive, but getting all these approvals, meeting all these is part of the price of something like this. And right here in particular, you see where it says that it meets section CW400 requirements as a temperature high limit control when configured for use with a 10K NTC sensor. So when I was talking about the 3-wire sensor meeting a certain code, that's what it is, and that's the section in the CSD1 code that requires you to have that type of sensor for high limit control. It's been approved for that kind of application. So now with a little bit of time left to go, I wanted to go back to the Bryan IOM. You can download this from the Blackboard site and save it. If you're doing preventive maintenance on a boiler like this is probably one of the things you want to look at. Right up here is a 20 by 25 standard furnace filter. You know, air pulls in right here. The air goes all the way underneath the cabinet on top, back here to where the combustion blower picks up the air. It pushes it through a heat exchanger that's right here. Flue gases are going the opposite way through that air-to-air heat exchanger. Then the air comes all the way back up to the front through a piece of pipe and goes into the burner there. The window right here, you can see the actual burner, and then the water tubes, and then finally the flue gases come through the heat exchanger and out the top there. On the display screen, I wanted to go over a few things so that if you working on a boiler like this, or like you saw there, Cleaver Brooks makes a similar one to this. When you touch the touch screen, it probably is going to be blank, because if nobody's touched it in 15 minutes or so, it will just go completely blank. But when you touch it and you see this picture, you might be tempted to push one of these buttons, either setup or this camera thing up here. But really, you just want to push this right here, because that will get you to the home screen. If you push the setup button, it'll immediately go to a keyboard screen like this, and you'll have to enter a password. You don't have the password to unlock it. If it's a Bryan boiler, I can get you the password. But typically, you would just push this, and you would get this screen right here. This is the home screen. This would tell you whether there's a demand, and central heat demand is the terminology they use. If the burner is running, firing rate, set point, actual outlet temperature of the water, the stack temperature. Obviously this one, the stack temperature sensor is not plugged in. And here is your actual flame signal. These run a flame signal from 0 to 15 volts, 15 volts being maximum. But you see across the bottom here, if you push this history bar, it'll give you fault history. I'll look at that in just a second. If you wanted to reconfigure something, you would push the configure button, the operation button, the diagnostic button, and here's some details which would tell you about the version history, things about the particular controller itself. But typically you would push the operation button here, and let's scroll down a few pages to show you what the operation screen looks like. It would be this screen right here. You can turn the burner on and off with this toggle button right here. It's not like a 120 volt switch or anything. It's just a software switch. Here, if you touch this yellow highlighted text here, it would take you to a screen that looked like this, and here you would change the set point. So first thing you have to do, because it was set at 180, you hit clear. That will all go away, and then you put in the 3 numbers or the set point that you want, push OK, and that will raise or lower the set point so that you can change set point. Here, if you open up the main screen and you see this is in red, that means it's currently locked out. When you go to the main screen, you would see this history bar here, shows lockout 67, IOK off, low water. And you push that bar, and then this will pop up showing that it's off. If it's beeping, you can hit silence. If you want to reset it, you can hit, I think it's lockouts here, and it'll allow you to reset that. But if you had this alarm, IOK off, low water, the first thing you would want to do is look at your low water cutoff. You'd open up the door, you find this low water cutoff, you'd look for a green light here, means it's powered up. A red light here means it's in alarm. Push the reset button there. One thing real quick, I think I got a little bit of time left. On the low water cutoff here, one common problem with these electronic low water cutoffs is that the circuit board is attached to the metal casing with these standoffs and screws, and these screws actually do ground the board to the standoff there. If that circuit board or these screws come loose, it does not get a good ground reference, and that will cause nuisance problems with these. So that's something to always look at. If you take the cover of a low water cutoff like this off, make sure that the board is securely attached to these standoffs, because if it's not, if it's shaking loose, that will give you some nuisance problems. Here is the fault history. Tells you at what time, what cycle. For this fault right here, the ignition failed, and the cycle here, you see cycle 3, cycle 3, cycle 3. That means that flame was lost in early run. Somebody pushed the reset button. It tried to ignite. It didn't ignite. Somebody pushed the reset button again. It didn't ignite. A cycle only counts if it goes all the way through and the main burner lights. If you see multiple cycle numbers in a row, that just means somebody's hit the reset button. It did not solve the problem. You know, you keep hitting the reset button. You're hoping that something's going to work. If that number doesn't change, you're not being very successful. Okay, I'm just about ready to run out of time. I'm going to make up the quiz for the third quiz for this, and I want to use all 4 of these documents in the quiz. One thing we haven't looked at very much is the display itself. This is the touchscreen display. It's going to be kind of important that you understand this in the future. You know, we're going to see a lot of this on equipment from now on. You know, touchscreen displays, you know, technology is not going to go backwards. So you're going to see things like this. And this is, you know, a touchscreen display for a boiler where you're actually configuring the air-fuel ratio. You know, this technology is going to keep going further and further. And this is the kind of stuff that you really need to pay attention to if you ever get the chance to go to a boiler manufacturer's school. I tell everybody, don't be so concerned about the mechanical parts of the training that they provide. Be more concerned with the technical stuff. That's what you really want to see and learn, is the technical side of the advances that they've made on new boilers and new equipment in the field that you're going to see. This is all really important information. So take a look through this. I'll ask some questions, and